In the first part of this lesson, you learned how to find the area of a triangle. The trick to finding the area of a triangle is to actually double the triangle and turn it into a parallelogram. What we're going to talk about today is the area of a trapezoid. It's the second half of the lesson. So what a trapezoid and a triangle have in common are that both of them, the way you find the area of the shape, involves doubling the shape to temporarily turn the shape into a parallelogram. So that process is going to feel a lot like what we did with our triangle. So that's why they're lumped together in the same lesson, because they're both shapes where you can double the shape and turn it into a parallelogram to find the area. So the trick to finding the area of a trapezoid is to create a parallelogram by doubling the shape. So when we double the shape, though, in order to figure out, well, how do I make the parallelogram? The trick to that is to flip the trapezoid. So create a parallelogram by flipping the trapezoid and adding it adjacent or next to the original shape. So remember, adjacent means next to. So looking at this first trapezoid example, if we were to flip the trapezoid upside down and slide it next to the other shape, it would end up going right here. So you can see that's an exact duplicate copy of the trapezoid. What we did is we just flipped it upside down. So since it's upside down, this is the 4.8 meters. And this is the 2.5 meters. And then the height is still the same, 4 meters. So that doesn't change. So once we turn it into a parallelogram, now we can find the area of a parallelogram. So the trick we have to realize with this, in this case, this actually makes a rectangle, but a rectangle is a type of parallelogram. So parallelogram and rectangle, both, the way that we find the area is by doing base times height. So in this case, the base is going to be this whole red section here. So in order to get the base, because the base is being made up of two pieces, we're going to have to add together the two pieces, the edge of the first trapezoid and then the edge of the second trapezoid that's flipped upside down. So to get that total red length, we're going to have to take 4.8 and add it to 2.5. So that's our base. So we know that to get the area of a parallelogram or a rectangle, we do base times height. So in order to get the base, we're going to have to put together a couple of pieces to get the full length of the base. And then the height is just right here. It's the 4 meters. So now this is just a work it out and calculate it out problem. So we could find the area of our parallelogram, or in this case, our rectangle. So if we go ahead and add the 4.8 and the 2.5, that gives us, oops, didn't mean to send that flying, that gives us 7.3. So that's our total base. The total length of the red measurement is 7.3 times 4. So base times height. So that gives us 29.2. Now, the thing we have to remember is 29.2 is this entire rectangle. So the 29.2 is this whole kind of yellow thing here. Kind of box all the way around it. So it is this entire thing. It's the 29.2. So we have to remember that. It's that entire thing. It's not the single black trapezoid. So this is actually two trapezoids put next to each other. So in order to find the area of just one of those trapezoids, we're going to have to divide by 2, because the 29.2 is the area of two trapezoids next to each other. So to find a single trapezoid, we would just split that in half. So the area of the original trapezoid before we doubled it is going to be half of that big yellow rectangle that we found the area of. So 29.2 divided by 2. And that gives you 14.6. So this feels a bit like a triangle calculation, because with the triangle we had to do base times height to get the parallelogram, but then we had to divide it by 2 because the triangle had been doubled. There were two triangles in there. So it's the same thing with the trapezoid. And then since we're working with area, make sure that your unit's correctly labeled. So there are two ways that you can label the units. So you could say meters squared, or you could say square meters. Those are both correct labels, but make sure that you're using the correct units, the correct labeling for your area since you're finding area. So that is the area of our trapezoid. So we're going to try one more, and then we're going to see if we can summarize this process into a formula, because we actually are walking through the steps for a formula. So you got one more trapezoid on here. So our process was to flip the trapezoid upside down and then put it next to the original trapezoid. So if we flip the trapezoid upside down, so that means that this is going to be the 4 meters, and the 7.6 meters is now right here. And so now we've got a parallelogram. So to get the area of a parallelogram, again, we do base times height. So to get the base of the parallelogram is this full length. So we're going to have to add together the 7.6 and the 4. The height of a parallelogram is right here. So the height we measure straight up and down for a parallelogram. So it would be 3. So to get the area, we would have to find the base. So to find the base, we have to add 7.6 plus 4. And then we multiply that by the height, which is 3. So we can go ahead and work that part out. So 7.6 plus 4 means that the total base along the bottom of the parallelogram is 11.6. And then we multiply that times height, because base times height. So we get 34.8. But you have to remember that 34.8 is for 2 trapezoids, because we have the upright trapezoid and the upside down trapezoid that we put together. So to get just one of those 2 trapezoids, I'm going to have to take this and I'm going to have to divide it by 2. So if we divide that by 2, then we get 17.4, and we're measuring in meters, so square meters. So that would be our area. So if you notice, when we flip our trapezoid upside down, in order to get the base of the new shape, so that's kind of the red part here, so right here, and then again right here and right here, because we have a right side up trapezoid next to an upside down trapezoid, the base of the parallelogram that we make ends up being the top base and the bottom base of the trapezoid added together. So trapezoids always have 2 bases, and the bases are the 2 parallel sides. So what we end up doing is just taking those 2 measurements, the bottom and the top of the trapezoid, and adding them together to get the base of the parallelogram. So if we wanted to generalize our trapezoid steps, we could say add base 1 plus base 2. We just have to remember that base 1 and base 2 are the parallel sides. And then we multiplied it by the height. And that gave us the area of the parallelogram, base times height. But since that parallelogram has 2 trapezoids in it, one right side up and one upside down, our very last step both times was we had to take that answer and divide it by 2 to get 1 trapezoid instead of 2. So we wanted to summarize the area of a trapezoid, these steps that we're going through, into a general formula. We could say add the bases, so the bottom plus the top to get the base of the parallelogram, times the height, and then divide by 2 because there are 2 trapezoids in the parallelogram. So that is how you find the area of a trapezoid. You are going to practice this a little bit on your practice assignment today. So when you're ready, you can go ahead and try your